once I've got it all sorted out. Okay, so we are going, what was it, page what? Page 23, roughly, we're at? Okay, so I kind of asked you to get to a roundabout question. I think I might have said question 11 in the previous lesson. And I would say that question 11, by the way, is kind of like an extension question, really. Oops, have I gone too far then? What happened here? I've gone back a page. Yeah, so if you manage to get question 11 out, well done. If you need me to sort of take you through it, please feel free to ask. We'll move on to the next page, which is these examples here, which is finding using using alternative information in order to work out the equation of the line. And it says specifically you need to find it in general form. Or some other form, I should say. Sorry, I'm being a bit slow. So we've got example 3. I'm not going to manually go through them. I'm just going to talk to them because I think, again, this is sort of stuff you already know, I think. So we've got here, find in general form the equation of the line with gradient 2/3 that passes through -2, -1. It says here that, oh man, let's go on to the video. I'm going to have one of those days. It says here that we've got, since the line has gradient 2/3, the general form of its equation is 2x minus 3y equals d. I don't like that. To me, that's like, I mean, I personally get why it's saying that, but I don't like it at all. So I might do my own solution to that. This is how I would do this problem. Just writing it down. I know you can't see it yet. So we've got gradient is 2/3, and it's got the point -2, -1. Okay, so this is the information, and we're told it needs to be in general form. So remember, general form is ax plus by plus d is equal to 0, or ax plus by equals d. Either way is fine. So I would probably start with this form because I know it best. Or I'd start with this form because it's more useful. Y minus y1. Now, y1 is -1, so that's going to be y plus 1. Minus 1 is plus 1, is equal to 2/3, the gradient, of x minus x1. And x1 is -2, so that becomes x plus 2. So I think that's the form I would use because it's the information I've got. I've got the gradient, I've got the point, so I'm going to put it into point gradient or gradient point form. Is that okay? That's the information I've got. I don't think I'd put it straight into general form because it's a bit magical doing that. Now I could expand it or I could get rid of the fraction. What shall I do? I guess I'll expand it. Is that okay? Next, I would get rid of the fraction, I think. So I'm going to multiply this entire equation by 3. I'll zoom out now so you can sort of see, got a bit more room to work. Is that okay? And now I'll put it into the right form. So which is going to be 2x. I'm going to have to subtract 3y from both sides to get the 3y on the one side. I'm going to either have... So it would either be this or 2x minus 3y plus 1 is equal to 0. Both of those would be general form. I'm giving you both. I don't like giving you both because it's kind of annoying. I'm giving you both because that's actually really I think, what most people would consider general form, but I suspect the answer in your textbook's going to look like that. What do you think? Anyone got any questions over that? Questions can be like, at this stage of the game, can be like, I didn't get any of that. It could be, wait, what's that form? Where did that come from? Where did line 1, 2, where did line 3 come from? Or what did you do in line 4? Anything like that. Generally speaking, I find that if someone asks the question, there's at least one other person that's going, oh, thank goodness someone asked the question. So you just need to be the brave person to ask the question. But at the same time, I don't want to just wait here forever if everyone's getting it. You sure? Okay, cool. So it's all about selecting the right form with the information that you've got. So I don't like how the textbook's done it, to be perfectly blunt. So the textbook's gone. Oh man, which one is it? This one? Nope. This one. So the textbook's gone straight into the general form of the equation. I don't like that. Instead, I'd be going, I've got the gradient, I've got a point, put it into gradient point form, and then, gradient point form, and then solving it from then. And you can see we've got the same answer, 2x minus 3y equals -1. What else? Oh, I didn't look at these questions up here. Was there an example beforehand I missed down the bottom? Nope. Might just do these question 12 and 13 together. Question 12, match pairs of lines which are parallel. So you can think about it yourself or discuss with the person next to you. Give you 30 seconds to come up with the match. Okay, so if we'll just do question 12 to start with, is there anyone that I cannot pick on? In other words, put your hand up if you don't want me to ask you. Everyone else is fair game? All right, we'll start with Izzy. What have you got? Give me one of the pairs. C and D? C and B. Okay, so if we have a look at this equation here, we can see there's a 3 in front of the x here, and there's a 3 where it should be for the point gradient form, and they're the same. So that looks right. Yeah? And it is right. It doesn't just look right, it is right. I just wanted to point out though, sorry, wrong one. If I did, oh man, now I can't remember what they were. Can someone call out what B was? Like that? And what was C? Okay, if I did this, I'm just going to add one little stroke of my pen. Is it still true? Good. If you said no, thought no, then good. If you don't see it yet, I'm going to spell it out just slightly. If I rewrite this into gradient intercept form, I would have y is equal to -3x by subtracting 3x from here and then subtracting 3x from here, -3x minus 2. So this gradient would be -3, and this gradient is 3. So I guess the warning I'm giving you is don't just look for the number in front of the x. Also make sure that if you wrote it in point gradient form or you wrote it in gradient intercept form, that would also, that numbers sign wouldn't change. The coefficient wouldn't change to a negative. So just be careful of that. Similarly, I could have left it as a minus and gone like -2y. This would also not be have the same gradient, right? Because if I add 2y to the other side and add 2 to the, if I add 2y to both sides and add 2 to both sides, I can get this, but that's not in gradient intercept form, right? The gradient intercept form says y is equal to something, not 2y equals something. So I'd have to divide through by 2 to get 3 halves x minus 2, well, minus 1. Okay, so that's two things to be careful of. Effectively, whether you do it in your head or you literally write it down, you need to be confident that if it were written in gradient intercept form or point gradient form, that form would have those m's agreeing in that form of the equation. It's not just the coefficient of x. It needs to be, it still needs to be either in your head or on paper, written in a way which m is clearly 3 or whatever. So is that okay? All right, I think I butchered the explanation there a bit, but hopefully it's clear enough. The other thing was, I actually didn't look at this beforehand, is this one I thought was a bit clearer. A and D were also parallel because if I subtract x from both sides, I'm going to get a minus x on both sides, so that's fine. Okay, do we have an answer for question 13 yet? I haven't done this ahead of time, so I haven't figured it out. I'll pause the video and give you 30 seconds more. And by giving you 30 seconds more, what I'm really saying is because I need 30 seconds to look at it myself. Okay, so I hope I've got it right here for myself. So match pairs of lines which are perpendicular. Iris, can you give me one pair?
One pair would be B and D.
B and D.
Oh no, sorry. The way I didn't actually write the which was which. I just kind of spent my time simplifying them. Sorry. I did it in order on here and then matched them, but I didn't actually really mark which one of those is. Oh, A and D.
A and D. So what you're saying?
I think so. I did them on here and then three on here. I just didn't actually put which was which.
Okay. That's a bit confuzzling. So we've got A and D. Emmy, what about you? Did you find a different pair to A and D? C and B.
I double checked and I do have that was A and D that I had as a pair.
Okay. Jack, did you have anything different? No. Eve?
I think A and C.
A and C.
So I think that's not so like because A has a gradient of negative a half
Mm-hmm.
and C has a gradient of 2, so that fits the one perpendicular negative 1 over n.
Mm-hmm.
But also D I think has a gradient of 2, so C and D could also be. I don't know.
Did anyone have any other different pairing? So we've got C and B. We've also got A and D and A and C. A, B, C, D. So they're all being matched with something at some point. Here's my working out. Just in slide 20 here. These are the three options that we were given. So you can see that what I've done in my working out is I've rearranged the equation so that I can see the gradients really clearly. So with the first two, I had to do a rearrangement. So the first one had a gradient of minus a half. The second one had a gradient of minus 2. And then we have C and D as having the same gradient of 2. That was explicitly, more or less explicitly given to us by the shape of it. So C and B is not right, but it's kind of close in that we definitely have a negative gradient here and a positive gradient here. So that match, that part of it is okay because reciprocal gradients do have opposite signs for their gradients. However, it also needs to be a reciprocal. So if you didn't get it wrong, it is A and C, and it is also A and D because both of those gradients are the same, right? So both of these match up with a minus half gradient in A for perpendicularity. Okay, so in general, I'm just going to have to go to the next page, which looks a bit blank. In general, if we've got y equals m1x plus c, and we've got y equals m2x plus c, we can write it a little bit like this. For perpendicular, m1 equals -1 on m2. We can write like that. That's how I tend to remember it, to be honest. Or the alternative way of looking at it is saying that m1 multiplied by m2 is equal to -1. So either of those ways are legit ways of looking at it. So when we have a look at those gradients, I'm going to flick over the page again. I hope that's okay. When we look at these, if you're not too confident on the whole reciprocal negative one, the negative reciprocal thing, you can also just go, if minus a half, when I multiply minus a half by 2, I get -1. So because when I multiply these two together, I get -1, these gradients must be perpendicular at right angles to each other. And obviously these two, the same things, it's the same number. Am I making sense? So multiply them together. If the answer is -1, you can say that they are perpendicular. We will come back to this idea a little bit later on as well. Let me see. I just want to have a quick flick to see if there's anything else I wanted to look at. I'll just try and verbalize this one, and then I'll let you do some of your own work. So this says find in gradient intercept form the equation of the line which passes through A3, 2. That means point A, which is found at the coordinates 3, 2, and point B, found at 5, -1. Now, just verbally go through it. I think this should be fairly straightforward. It's used the 2 points to work out the gradient. So you've got two, well, it's gone this way around. So you've got -1, -2, and 5, -3. That gave them a gradient of -3/2. Then it's used, then it's put it into point gradient form. So it's used one of the points, 3, 2, to put it into point gradient form. It's then expanded it and added 2 to both sides to get it into gradient intercept form. Some of you might be used to just putting it straight into gradient intercept form and then substituting a point in to work out C. That's legit as well. Both of those things are absolutely fine. This is probably a bit more efficient, but y equals mx plus c is the thing that we're most familiar with. Okay, so I'm going to stop there. I'm going to put some work on for you to do, which is just a few more from exercise 1A. And then in about 15 minutes, I'm going to go through a little bit more theory, and I'll do a separate video for that one.